Okay, next we have another contribution from Caroline Alliston and the Institute of Mechanical Engineers with the Technology for Fun initiative. This time, she's a good question. I've forgotten what it is she's going to talk about. It's got to that time of the day. Of course it is. It's the colour spinner. So this is something you can make at home as well. And thank Caroline for submitting this contribution.
Hello, I'm Caroline Alliston, a Mechanical Design Engineer and STEM Ambassador. This is what we're going to make today. It's a coloured spinner. I'm using it to mix light of different colours. I'll show you what it does. Here I'm mixing red and blue on the outer ring, green and blue on the middle ring, and red and yellow on the inner ring. Look what happens when I spin the disc. You'll need paper, a pencil about 16 to 20 centimetres long. Hexagonal ones are better than round ones. A plastic bottle or tube. I'll show you some examples. These are plastic drinks bottles. Here's a shampoo bottle, sunscreen bottle. And this is a fizzy tablet bottle. It needs to be about 5 centimetres shorter than the pencil. A shorter pencil, an old CD or DVD, 2 milk bottle lids, and some string. And you'll need a ruler, scissors, felt tip pens, sellotape, and some blue tack. Step 1 is to cut out the paper discs. So place the CD on the paper and draw around it. Make a cross in the middle. You should be able to get 3 discs out of one sheet of A4 paper and then cut out the 3 discs. Step 2 is to cut out the centre of the discs. Put a lump of blue tack on the table. Put the first bottle lid open end down on the blue tack. Push the pencil straight down in the middle of the lid to make a hole. This is so you can find the centre of the discs. Place the lid over the centre of the paper disc and draw around it. Place the disc on the blue tack, push down with the pencil to make a hole in the middle. Now cut out the circle and then repeat for the other discs. Step 3 is to make the spindle. Place the second bottle lid on the blue tack with the open end up. Push the pencil straight down into the bottle lid in the middle. Push the bottle lid along the pencil until it's almost at the other end. Roll a piece of blue tack and then attach it to the bottle lid. Slide the CD along the pencil and squeeze the CD and bottle lid together to squash the blue tack. Roll a second piece of blue tack and attach this to the other bottle lid. Push this bottle lid along the pencil to the CD and squeeze the two bottle lids together. Step 4 is to attach the string. Measure and cut a 60cm length of string. Make a slip knot in one end. I'll show you how to make a slip knot. You loop the string round your finger and then you push this end of the string up through the loop. And you put it round the small pencil. This is to make the handle, and you pull it tight. Now I'll show you the other end. So leave a reasonable length, wrap it round your finger, make a loop, push this end up through the loop, put it round, put the pencil through it, slide it up near the top and pull it nice and tight. Step 5 is to try out the spinner. Slide the long pencil into the bottle or tube. The slip knot should be about 1 cm above the top of the tube. Hold the tube on its side and turn the CD with your finger to wind the string around the pencil. Hold the tube vertically and pull the handle away from the tube to spin the spindle. As soon as the string is fully out, start to bring the handle in again. The spindle should carry on turning and wind the string back in. Once the string is in, pull on the handle again to turn the spindle. Step 6 is to try mixing colours. You can make concentric circles on the discs by drawing round glasses of different sizes. This lets you try different colour mixing effects on one disc. Now I'm dividing each circle up into 8. Here's one I've made earlier. I've tried mixing pairs of primary colours. You attach the disc onto the CD with sellotape and then spin it to see what effect you get. Step 7 is to try different effects. This one is a Maxwell disc. The colours green, red and blue will combine as it spins to give grey. Then in the middle we've got black and white, which also combine to give grey. The idea is you increase the proportion of black until the shade of the inner circle matches the shade of the outer circle. This one is a Newton disc, where I've used all the colours of the rainbow. A rainbow is where white light from the sun is split into its component colours by raindrops. So if you combine all the colours of the rainbow in the right proportions, you should end up with white light. So I'm going to stick it over this and we'll see what it does. You can create your own effects. I've got some examples here to show you. My son is a physics student and he's going to explain the science behind the project.
White light is made from a mixture of colours. I can use this CD to split the light from this torch into its separate colours. Here you can see the light is being dispersed by the CD. The different colours in the light are dispersed by different amounts, so the separate colours can be seen. So if white light contains all the colours of the visible spectrum, then by mixing these colours together in the right proportions, you should be able to make white light. This is how the Newton disc works, although it's very hard to get perfect. In order to see a coloured object, light has to reflect off the thing and into your eye. So the reason this cup appears red is because it reflects only the red coloured light, and it absorbs all the other colours of the visible spectrum. We have 3 types of colour receptor cells in our eyes, which detect most strongly the colours red, green and blue respectively. The brain then combines these signals together to interpret the colours that we see. This is why pixels on a colour display use red, green and blue LEDs, mixed in different proportions, to give a wide range of colours.
Thank you for watching. This project is taken from my book Build It, 25 Creative STEM Projects for Budding Engineers. For more ideas you can visit my Technology for Fun website. I hope you enjoyed this project and plan to video more fun, exciting STEM projects over the coming weeks.